Hello everyone, I'm Jasmine Mahapatra, currently studying in Bangalore Institute of Technology, and I'll be presenting the topic parallel and serial out shift register of the subject analog digital electronics. So let us just study the basics of the registers, which are flip-flops. So flip-flops can be used to store a single bit of binary data, 1 or 0. However, to store multiple bits of data, we need n flip-flops, multiple flip-flops. So n flip-flops are connected in an order to store n bits of data. A register is a device which is used to store such information. It is a group of flip-flops connected in series used to store multiple bits of data. So what exactly is a register? It is formed by connecting n flip-flops to store the information to store the binary data, right? Then the information stored within these registers can be transferred with the help of shift registers. So the information that we have in these registers, they can be transferred with the help of shift registers. That is a type of register which usually helps in the shifting. So shift register is a group of flip-flops used to store multiple bits of data. The bits stored in such registers can be made to move within the registers and in or out of the registers by applying clock pulses. So these shift registers, as I told, and as it is written in the points, it is used to transfer the data, and it is transferred with the help of clock pulses. Okay, so when you apply the clock pulses, only then the data is transferred from one flip-flop to the other flip-flop. Okay, an n-bit shift register can be formed by connecting n flip-flops where each flip-flop stores a single bit of data. So let's carry on. The registers which will shift the bits to left are called shift left registers. The registers which will shift the bits to right are called shift right registers. So there are two types of shift registers. That is the one that actually shifts the bits to the left, that is known as the shift left, and the ones that actually shift the bits to the right? So that is known as the shift right registers. So shift registers are basically of four types. These are serial and serial out shift register, serial and parallel out shift register, parallel and serial out shift register, parallel and parallel out shift register. So I'm going to speak about parallel and serial out shift register. So parallel and serial out shift register, also known as PISO, the shift register which allows parallel input and produces a serial output is known as parallel and serial out shift register. So it is so in this type of register, you have the inputs that comes in parallelly and you get a serial output, right? Then the parallel and serial out shift register stores data, shifts it on a clock by clock basis, and delays it by the number of stages times the clock period. Parallel serial out means that we can load data in parallel into all stages before any shifting ever happens. So what this exactly means is that it's going to load in all the inputs that you give in parallelly, right? So it will be first loaded into all the stages, and then only the shifting happens. Before that, it won't happen. So first you store all of those datas. You store all of those datas in the stages, and only then the shifting will happen. Then a way to convert data from a parallel format to a serial format. By parallel format, we mean that the data bits are present simultaneously on individual wires, one for each data bit as shown below. So he's just telling that the data that is going to be given in parallelly will be present on their own individual wires. We are going to see it on the next slide. So this is what he means. The data inputs will be given parallelly, right? So it will be given in data DA, DB, DC, DD. So these are their own individual wires, and they'll be given the parallel inputs, right? And this is the output, and these are the different stages. This is the clock. So then let's go to the next one. So here then it's going to talk about the three stages in the most internal details. Okay, so we're going to learn the internal details of a three-stage parallel and serial out shift register in the next slide. So basically it's going to say that the D flip-flop is used for the storage, and the AND OR is used for whether the data will load in parallel or shift the stored data to the right. So here the D flip-flop is used for the storing of the data, and the and in all combinational circuit will either tell if the data will load in parallel or shift the stored data to the right. So mostly the shifting happens towards the right. That is when we use the shift right register, right? Okay. So I'm going to tell the working of this in a much more simpler way. So here it is. So we have two modes in this parallel and serial out. This is known as the load mode or the shift mode. So here we have B0, B1, B2, B3 as the parallel inputs. It's going to take in the inputs parallelly, right? And this is the shift load complement. So this load happens only when this value is 0, when this input is low. So this is when the loading happens. So we have to remember that the loading happens when the input is 0 over here, when it is low, and B0, B1, B2, B3 are the parallel inputs. And this is the clock, as we know that the clock actually will help in the shifting process. That is the next mode. So let's just see. So here we have 0 as the uh, it's 0, right? Then we have the NOT gate over here. So here it becomes 1 and here it is 0. And here we have, okay, before all that, I also have to tell that the B0 is connected to the flip-flop 0. Then the B1 is, the Q0 is used as the input for the flip-flop 2 over here. See, this is the combinational circuit that is used, and this acts as the input of one of these AND gates. Similarly, the output of this flip-flop is taken as the input of this AND gate, and here is the input, and then again we have the output Q2, which will be taken as the input of this AND gate, and then here again we'll do the calculation and I'll show you, and then we have Q3 as the output again, right? So here we have given it as 0. So since we have a NOT gate, we are going to give here 1, and then here it will be 0, and then here we have B0. So B0 would be the so B0 is over here, then you have Q0. So Q0 will be given to one of these AND gates. And then since it is 0 over here, since it is connected to one of these, so one of the inputs will be 0 and one of these inputs will be 1. So the AND gate, the input of the AND gate 1 is Q0 and 0 from this. And here the AND gate 2 would be, the input would be 1 and the other input would be B1, right? So here we have Q0 and 0. Q0 and 0 would be 0, right? And 1, see, and 1 and B1 would be B1 according to the truth table that we know. And then we have the OR gate over here. So 0 and B1, so this would be B1. So the B1 acts as the input for the flip-flop 2, right? And then we have Q1 over here. So Q1 acts as the input of the gate of the AND gate 3, and 0 is the other input for AND gate 3. And for the AND gate 4, we have the two inputs 1 and B2 because it's connected to 1 over here and B2 over here. So here similarly the output would be 0, and here the output would be B2, and here we'll get it as B2 as after the OR gate. Then after that, because 0 and B2 is B2, right? Then we have B2 as the input. Then we have Q2 as the input for the gate 5, right? Also 0 as the input for gate 5, and for gate 6 you have the input as 1 and B3. So here, since it is Q2 and 0, your output would be 0, and here 1 and B3 you'll have the output as B3, and 0 and B3 for the OR gate would be B3. So, and then you get the Q3 as a serial output. So this is how you actually do the loading mode. So whatever you have here, like here it would be B0, here would be B1, so this would be B0, flip-flop 0, the loading would be B0, B1 here would be the load of the second flip-flop, B2 here, because see we have written here B1, B2, and B2 would be the load for this flip-flop 2, and B3 would be the load for flip-flop 3, right? Then, so here we have just told that since we are not using the clock over here, so it will be known as a synchronous load because the data is synchronized to the clock. But since, sorry, this will be the asynchronous load because it does not require the clock, and the clock, wherever the clock is required, it's going to be the synchronous load because the data is going to be synchronized to the clock. Here in the second diagram that we are going to learn is when the shift and the load will be 1. So the previous what we learned is when it is shift and the load complement is 0. That only happens in the load mode. So we are going to learn when it is 1, when the shift and load complement is 1. This usually happens in the shift mode. So shift mode, what exactly happens is that the load that you have given into these flip-flops, it will be transferred to the next flip-flop with the help of clock. So the clock pulses really help you to shift the inputs from one flip-flop to the next flip-flop. So let's see how it is done. So here we have just taken it as 1. Here, because the NOT gate would be 0, here it would be 1, here would be B naught, here would be again 1 0 1 0 and 1 0. Here would be B naught, as we know. So whatever input you give there would be over here, and then here one of these inputs is Q naught and 1, so it would be Q naught over here, and here it would be 0 and B1 because see there's the NOT gate here, right? So since it is 1, so it will be 0. So all the values in the first line will be 0 and all the values in the second line would be 1. So one of these inputs for the first gate would be Q naught and 1 because Q naught from the previous flip-flop has taken as the one of the input and 1 for the first AND gate. So here Q naught and 1 would give you Q naught as the output. Then the second AND gate you have 0 and B1. So 0 and B1 would be 0. So Q naught and 0 in the OR gate will give you Q naught, which is the input of the second flip-flop. Right? Then we have Q1 as the third AND gate's input along with 1. So Q1 and 1 will give you Q1 here, and 0 and B2 will give you 0 here. So it will come as Q1 and 0 will give you Q1 here, which is the input of the second flip-flop. Second flip-flop. Here, because it's 0, 1, 2, so we'll tell either we can tell it as a second flip-flop according to these numbers or the third flip-flop. And this Q2 would be given as the input of the fifth AND gate, and 1 is also the input of the fifth AND gate. So Q2 and 1 will give you Q2 as the output here, and 0 and B3 will give you 0 over here. So Q2 or 0 will give you Q2 over here because of the OR gate. And then this is the output Q3. So now what happens is that when you so what exactly happens is that, see, Q1 ka input is for flip-flop 2. Q0 the input is, so see, we can just know it from this diagram that Q0 is the input for this, so it will be loaded here. Q1 will be loaded in the flip-flop 2, and Q2 will be loaded to the flip-flop 3, and Q3 is known as the serial output. Okay, now let's take an example. If we have taken the parallel inputs as 1 0 1 1, then first the loading will happen, right? So when the loading happens, the shift and the load complement, here it should be low, so it should be 0. So all the inputs that you have given will be loaded to their particular flip-flops. That is, for FF0 would be 1, for FF1 would be 0. Because we have learned, right, in the previous slide, that whatever you give here, B0 will be for FF0. See, B1 input of this, B2 input of this, B3 input of this, right? Yeah. So that is how the loading really happens in the load mode. And when we need the shift mode, so for the shift, what will happen is the clock pulses are there to the clock is there to give clock pulses for the shifting mode to happen. So what happens is after the load is done, this Q0 becomes, so Q0 what do we have now? 1, right? So after this the 1 will be here, so the Q0 becomes 1 over here, and here it becomes 0, here it becomes 1, and here it becomes 1. It just shifts to one place to the right. That is what happens in a parallel in serial out register. Okay, so here we have the waveform. It's just a similar thing. So you have the clock, we have the shift load complement data in DADBDC. So DADBDC is 101. That is, this waveform is given in the form of, okay, just give me an example, right? Okay, so here you have DA, DB, DC. It's just an example, don't get confused. So yeah, this is according to this, whatever is written here. So you can just read through to understand what exactly it means. So DA, DB, DC, these are the inputs 101, and then it is given to the flip flops. It is loaded to the flip flops. So 101, these are basically the outputs of their basic flip flops, and then it is given out, right? The like we load it. So the inputs and then it's loaded in. So QA, QB, QC is the loading data of the particular flip-flops, and DADV, DC are the inputs that we have given. Okay. Similarly, this is for the this is for the shifting mode. Your 101, and then first one is given here, then 0 will be given here, and then 1 will be given here, and then 1 again shifts, 0 shifts, and again 1 again gets shift, and it goes out, right? So you can go through this to understand what exactly it is. Now these are few of the parallel and serial out devices that we have. These are the four basic devices that we use it. So we have SN74ALS166, which is a 8-bit shift register for synchronous load. Then we have SN74ALS165 for asynchronous, CD4014B for synchronous load, and SN74S647 for the synchronous load again. So, but this is for the 16-bit shift register. Okay. So the applications of parallel and serial out are: the shift registers are used for temporary data storage. The shift registers are also used for data transfer and data manipulation. A parallel in serial out shift register is used to convert parallel data to serial data. An application of a parallel in serial out shift register is to read data into a microprocessor. Okay, so these are the few applications, and we'll see the alarm with the remote keypad, right? So this is the keypad, and this is the ground, this is the clock, this is serial data, and this is the 5 volts that is given. This is the keypad, this is the alarm. So let us see what exactly happens. The alarm above is controlled by a remote keypad. So the alarm over here is controlled by the remote keypad as it is given. The alarm box supplies plus 5 volts and ground to the remote keypad to power it. So it also provides 5 volts and ground to ground to the remote keypad to power it. The alarm reads the remote keypad every few tens of milliseconds by sending shift clocks to the keypad, which returns serial data showing the status of the keys via a parallel and serial out shift register. So here the alarm reads the remote keypad every few tens of milliseconds by sending shift clocks to the keypad. So it reads the remote every time by sending shift clocks to the keypad, which turns which turns all the which returns serial data showing the status of the keys via parallel and serial out shift register. So this is reading switches into a microprocessor, because we have it. I mean, a microprocessor is also an application, so that is a diagram for it. Not important to learn. Then a practical application of a parallel and serial out shift register is to read many switch closures into a microprocessor on just a few pins. Then parallel to serial conversion, where they are used to reduce the number of wires or lines needed for communication between two devices, since serial communication generally requires just two wires compared to parallel, which depends on the number of bits being sent. So this is what we have learned for today, and hopefully this has helped you. And thank you for giving your valuable time. Thank you so much, and have a nice day ahead.